Hello, Math 2. I'm Mrs. Bricky, and this is uh, Unit 8, Lesson 2. We're going to be talking about non-factorable quadratic equations. So not every quadratic is a factorable quadratic. In fact, there's a lot more unfactorable ones than there are factorable ones. So here's an example of a non-factorable quadratic. Our ending number is 13. So if we wanted to try to factor this, we'd fill in our x's. We'd think about that number 13, and the only factorization of 13 is 1 times 13. But there's no way to get a middle term of 3x with those two factors. So this is not factorable. So if you have a quadratic that is not factorable, there is still a way to get your two solutions. And that way is called a quadratic formula. So the quadratic formula tells us that if we have a quadratic in standard form that is equal to 0, like ax squared plus bx plus c equals 0, where these are numbers, a, b, and c are numbers, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that is probably the most complicated math formula you have seen to date in your math life. But you're going to practice it and you're going to get good at it, even if it does look a bit intimidating at first. So a couple of notes about this formula. A, B, and C are numbers. So everything on this right side of this equation is a number. And we'll learn how to simplify and evaluate what that number is, but everything on that right side is a number. The only x in the equation is this x right here on this side. The equation must be equal to 0 in standard form to apply the quadratic formula. And then probably the easiest place to make an error with this formula is right here with this b squared. B squared means square all of b, including the sign. So if you had like a -5 as your b value, you want to put it in parentheses when you square it in your calculator. All right, so we're going to try a couple now. We're going to start with that equation that I just showed you a moment ago, x squared minus 3x minus 13. So we want to think really hard about what the coefficients are here. X squared doesn't have a number in front of it, so we understand that to be that there are one of those x squareds. Our coefficient for our x is a -3, and we need to think about the negative with the 3 and include that as our b value. And our c value is also negative. It's a -13. So we're going to sub those into our quadratic formula. So the first part of the quadratic formula is the opposite of b. So we're going to put our b value inside there. Plus or minus the square root. Under the square root, we have a b squared minus 4 times our a value multiplied by our c value. And then that is all over 2 times our a value. So you can see on that right side, I only have numbers. There's roots and other math symbols, but there's no variables. So the next step, and I have a little checklist over here on the side, we have identified and subbed in a, b, and c. The next thing that you want to do is simplify inside the radical. Now, we don't want to type the radical into our calculator. We just want to figure out what this number is. So if I calculate that, -3 is in parentheses, squared minus 4 times 1 times -13. And my calculator tells me that that is 61. So I'm kind of just focusing on the radical right now. This is a -3, so that's 3. And the bottom is a 2. And my calculator just calculated that inside number to be a root 61. So we've simplified our radical, or simplified that inside number. Now, sometimes you'll have additional steps to do. For example, you may be able to simplify this radical. But if I type in that radical into my calculator says that it is just root 61, so that's already in simplest terms. There are also times where we'll have to simplify the fraction, but in this case, my fraction does not simplify either. So that is our final answer right there. Whoops, JK. Let's put a pretty box around it. X is equal to 3 plus or minus root 61 over 2. Now, when we talk about quadratics, we talk about how they always have two solutions. And this is two solutions. One of the solutions is this, 3 plus root 61 over 2, and the other one is this, 3 minus root 61 over 2. So remember that plus or minus symbol is just shorthand so that we don't have to write all these radical fractions first. Okay, let's try it again. We've got x squared plus 12x plus 8. So our a value is a 1. Our b value is a 12, and it's a positive 12. And our c value is a positive 8. So we've got a bunch of positive ones this time. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over 2a. All right, so we've got our a, b, and c substituted into our equation. We're ready to figure out what that number inside of our radical is. So we've got 12 squared minus 4 times 1 times 8, and that is 112. So our equation looks like we've got a negative 12, we've got a 2 on the bottom, plus or minus, and that number inside of our radical is a 112. So we've got the inside of our radical simplified. Now we're going to see if that radical reduces. The square root of 112 is 4 root 7. So I'm going to put that into my equation. Negative 12 plus or minus 4 root 7 over 2. So we have now simplified our radical. And in this case, we can even continue simplifying. We can simplify our fraction. So we've got a negative 12 plus or minus 4 root 7 all over 2. Well, the top has these two terms, this negative 12 and this 4 root 7, and both of those are divisible by 2. So you can think of it as like separating it into two terms if you want, with each of them having that divide by 2 with them. So that first term is a negative 6. And then in the second term, when you have a radical, the inside doesn't divide. It's the number in front that you want to divide. So 4 divided by 2 is 2. So this is 6 plus or minus 2 root 7. And that is our final answer. And again, that is two answers, negative 6 plus 2 root 7 and negative 6 minus 2 root 7. And you don't have to separate it like I did. I just say it so that you understand that that is two answers to our equation. It's also not necessary to write this step out. If you just want to kind of think about dividing each of those from this step, you can. One of the most challenging parts of the quadratic formula is simplifying your answers. So I just have a bunch of answers that we're going to try to reduce, if possible. Some of them are not possible to reduce. So if you are trying to simplify your fraction here, the denominator must divide both of the terms in the numerator in order for that fraction to reduce. In the second term, it's the coefficient of the radical that you can reduce, not the radicand. We don't reduce the inside of the root. We only can reduce the coefficient of the root. So on that first answer there, 4 plus root 5 all over 2, that one is simplest terms already. We can't reduce it. Now the 4 divided by 2 looks like maybe that could reduce if we, that one could reduce, but the second one with the root 5, its coefficient is 1 and the 1 does not reduce. So this one is in simplest terms. 15 minus 8 root 6 over 3. Again, you kind of see that 15 and the 3, and your brain might be telling you, oh, this one can reduce. But the coefficient 8 is not divisible by 3. So this one is also in simplest form and cannot be reduced. The rest of these are able to reduce. So 12 minus 3 root 19 over 3, that can definitely reduce. You can think of separating it if that helps you. So this would be 4 minus, and that reduces to a 1, root 19. It's if you want to go straight to your answer and you can't do that, that's fine. Otherwise, write it separately like this. So let's think about this one. If I wrote it separated, it's a 2 over 2 minus an 8 root 6 over 2. So that first term is going to be a 1. It's very easy to lose that term, to have your brain trick you into turning it into a 0. But that is a 1. 2 divided by 2 is 1. And then minus 4 root 6. This last one is an example of the most difficult type to reduce. So the 6 and the 8 don't simplify to a whole number, and the 14 and the 8 don't simplify to a whole number, but all of these terms have a common factor of 2 that can reduce. 6 is 2 times 3. 14 is 2 times 7, and 8 is 2 times 4. So we can reduce that factor of 2, which leaves us with 3 minus 7 root 2 over 4. And as we're working with these, we'll have different quadratic formula problems where we'll be able to practice reducing these type. They are really challenging though. Okay, here's our next one. 3x squared plus 5x is equal to 3x plus 70. So in this case, we do not have equals 0 yet. So in order to apply the quadratic formula, we need to manipulate our equation a little bit, move some terms around so that we will have it equal to 0. And then we also have a 70 over here. I'm going to subtract that. Now, there's not another term for it to combine with, so I'll just put it over at the end. Okay, so we, in this equation, have 3x squared. If I combine the 5x and the negative 3x, that gives me a coefficient of 2. And then our constant is that negative 70. So x equals negative b plus or minus the square root of b squared minus 4 times our a value times our c value, and that is all divided by 2a. So we've got negative 2 plus or minus a root over 6. Let's figure out what number is inside of that root. 2 squared minus 4 times 3 times negative 70 is 844. So we identified and subbed in our a, b, and c. We simplified our inside number. Now we're going to reduce that radical. The square root of 844 is equal to 2 root 211. So I'll change that root 844 to a 2 root 211. And now, so we've reduced our radical, and now we need to try to simplify our fraction. Well, 2, it looks like they all have a factor of 2. This is 2 times 1, this is 2 times 1, and this is 2 times 3. So they all have a factor of 2 that can reduce. So this leaves us with negative 1 plus or minus root 211. You can have a 1 in front of that root if you want, and it's all over 3. So those are our two answers to this quadratic equation. Okay, last one. X squared plus 63 is equal to 16x. So again, this is not in standard form equals 0. So we've got to move some terms around so that we can identify our a, b, and c. We need to subtract the 16x, and it's going to go right in between those two. So x squared minus 16x plus 63 is equal to 0. So it looks like for this quadratic, our a value is 1, our b value is negative 16, and our c value is 63. So x is equal to, and I purposefully didn't put your guided form on this one on your paper notes so that you can start practicing writing it out on your own. X equals, and you'll get the quadratic formula on the test. You do not have to have it memorized. We will give that to you. No need to memorize. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, and this is all over 2 times a. So x is equal to 16 plus or minus some radical over 2. So let's figure out the number inside that radical. Negative 16 is squared minus 4 times 1 times 63. That gives us 4. Huh. Interesting. All right, so we identified our a, b, and c. We simplified that inside number. We're ready to reduce our radical. Well, I don't even need a calculator for this one, but you could use your calculator if you want. The square root of 4 is 2. So we're going to substitute a 2 in, and that 2 does not have a radical. 16 plus or minus 2 over 2. When this happens, and this does occasionally happen, when this happens, you want to keep going because this is just a number, or two numbers, I guess. So we want to get those two numbers. So 16, I'm going to separate it into two equations. 16 plus 2 divided by 2, and 16 minus 2 divided by 2. Well, 16 plus 2 is just 18. And 18 divided by 2 is 9. 16 minus 2 is 14, and 14 divided by 2 is 7. So we really just have the answers 9 and 7. And if you use the quadratic formula and you get down to your answers and they are whole numbers, you know what that means? It means that your quadratic was factorable. X squared minus 16x plus 63 is factorable. The factors of 63 that add up to negative 16 are 7 and 9, both negative in the factors, which gives us the solutions 7 and 9. So if a quadratic is factorable, you absolutely can apply the quadratic formula and it will work, but it is challenging to simplify. And to me, this amount of work is a lot more preferable than this amount of work. So watch out for ones that are factorable, because if you notice one that's factorable, you can absolutely factor it to get your answer. All right, that is it. So practice up with the quadratic formula. This was just part 1 of the lesson, so practice your quadratic formula a bit, and then if you missed class, watch part 2 as well, or part B as well. Thanks so much.